Alright, so I think we left off with first reference surface established. We machined and scraped in basically the bottom of the dovetails on the table. And my next step I thought was going to be establishing a true sort of repairing the dovetail on the fixed side of the table here. I've had a little bit of change of plans. What I think I'm going to do is try to get all of the geometry in before I get into any more of this scraping. So in order to take good measurements on the male dovetails and good measurements on the female dovetails, I'm going to have to mill out a lot of that wear that's there, and I'll sort of explain why. So far we've been taking relative measurements, so the deviation of this surface from the top surface of the table. So I'd like to get sort of some objective measurements of actual deviation from a common reference surface. I think that'll make sense as we get into it. So what we'll do is we'll go through and I'll show you how I did all the measurements. I wanted to get sort of a survey of all of the wear between the two parts, make sure that wear jives up and everything makes sense before I start cutting material. Meanwhile, I had to order the Dovetail Cutters. These are 55-degree dovetails. And I have 45-degree cutters and I have 60-degree cutters. But I don't have a 55. At first I thought I would just put a 45 in here and just tip the head and work on these two surfaces separately, but then when I moved to the other side I would have had to tip the head the other way, and I just would rather introduce as little error as possible. While we wait for those to arrive, I thought I could show you how this wear was mapped out, what the plan of attack is, and I thought we could work on this on the gib here. The gib has a significant amount of wear in it, and it's actually a bit peculiar how these two parts, wore in together, or not the way I would have expected the wear. I assumed sort of symmetric front to back, but it turns out not to be that way. Let's take these over to the surface plate and we'll walk through this a step at a time. I'll go through it somewhat quickly. I won't show you every measurement that I took, but I think you guys will get the idea of what's going on here. I'll meet you over at the surface plate. Let's have a look at the state of the gib now. Just as a little aside, I really lucked out here in the sense that this is a straight gib. If this were a tapered gib, this project for me, at least just with my comfort level, would have been next to impossible. The tapered gib would have had very long, scraped surfaces on essentially four sides. Tapered, very extremely sensitive. The straight gib has one machined surface. This is a non-wear surface. This is inside the machined side of the dovetail under the table, and these are where the little pins and the screws come through, and it can be adjusted. Let me turn this over here. So the pins come through the back, and there's sort of this adjustment that you can make in the dovetail. Whereas a tapered gib, it's got to come in perfectly parallel as you're adjusting it along the length of the table. So we have somewhat of a reference surface here because this has never moved relative to anything it hasn't worn. And in fact, if I put this down on the surface plate, there's really no bend or bow or rock or anything in it. And if I kind of scan below it with my flashlight, I can see no light across the bottom of that. So I'm confident that that bottom surface is still flat. Instead, if we flip this thing over, probably you see it from even as far away as, let me zoom in on that. So that's the 20 thou. That's the machine side. Now this wear measurement was very straightforward. I mean, I've got the flat side down on the bottom. I got a stare at thousandths indicator, and I just sort of zeroed it somewhere and swept it along the length. If I put the indicator down on one end and I try to push this around and rock it, I don't really get any motion there. So we're going to have to machine 20 thou off each end here, spot, and scrape this flat. I still haven't figured out exactly how I'm going to hold this. This is going to be a bit of a trick to machine. Another bridge will cross when we get to it. So to get a read on the wear on the inside of this female dovetail, I'm measuring across this ground pin. This, in this case, is 8mm pin. It's a hair over 300 thou, I think 310, 312, something in that range. The pin is sized so it's about halfway up that dovetail surface. And basically just came in, zeroed out the indicator, marked that as 0, and just bumped my way down the dovetail, taking those readings. Now I was sure to clean the inside of this out very well. I also went in and clearanced the bottom of the dovetail a little bit with just a hacksaw blade. Just went in and cleaned that up a little bit along the length. We're going to be machining some of the male dovetail off, so I don't imagine that being a problem there, but I'm worried that the edge of the straight edge that I'll be using to spot the surface might interfere in there, so I took a hair out all the way along the length. You might be able to see that that's a little bit shinier down there. So this turns out to be 1.5 thou, just a hair over, 1.6, something like that, in the center. I also double checked that with a micrometer reading. So in addition to the indicator reading from the surface plate that we just saw, I went in and just, sort of a bit of a sanity check, as many measurements as I can to establish or to build some kind of confidence in what I'm actually seeing here. And here I'm just using a 1 to 2 inch micrometer over the same pin and just coming down and carefully locking that, taking that reading, and this will go down to tenths, and just marking that in the same location. So in blue I've got the relative reading from the indicator, and in black I've got sort of the objective actual measurement of that dovetail. And that seems to jive up with the same measurement. And again, that reinforces the fact that I feel confident that this is a good reference face. I did the same thing over on the other side. So what I did is I went through with the pin and I measured the machine surface all the way down the length and marked that. There's 1 thou deviation between this end and that end that's 25 or so inches away, which is pretty darn good, I think, for this is a machine surface in here. I did the same thing with the pin that we did on this other side with the gib in place, took that measurement, subtracted the difference I measured without the gib, and still ended up at that 20 thou wear in the center. So I'm pretty darn positive this thing's got 20 thou wear in the center, and this side's got 1.6 thou wear in the center. So it's very uneven wear, and to be quite honest, I was surprised about that. This steel on cast iron interface wore more than the cast iron interface. I mean, maybe it worked. I don't know what this thing used to grind in its past life, but maybe it worked up against the back of this gib more than it worked up against this gib. Hard to say. Alright, so I hope this isn't too boring. I just wanted to show you the sort of the measurements on the male dovetails, or at least the way I've been taking them. I mean, for anyone that is considering doing something like this and maybe hasn't done it before or doesn't have a lot of access to information, personally I find the whole measuring process to be the trickiest bit. And that, trying to figure out exactly where you need to cut and how much compared to the actual, mechanics of scraping, though that's certainly an art form in itself. So we're still measuring over pins here. And so it's the same set of ground pins, 8mm, and we're about that halfway point up the dovetail. Now the first thing I wanted to do here is just come across this with a big micrometer. You can see I can get one side in there on that dovetail, but this side there's some interference with the actual sort of the threaded portion that the barrel screws into. So I can't get that measurement because the micrometer is skewed because of that height difference. Now I think what you could do is maybe go up to the next size micrometer and then use like a standard. So this is hanging out here and you have a constant, 1 inch or ½ inch or whatever spacer you need. But unfortunately, I don't have a 5 to 6 inch micrometer, so this isn't going to help me out much. The other thing I did, just to sort of get a gut check, and some people might cringe when they see this, is break out the old digital caliper. Now I don't use these much. I like the mechanical style, but if I'm doing a lot of inch and metric conversion, or if I need to make reference measurements to an absolute zero, these really are quite handy. So I just sort of turn this on, put this across the pins just like you would with the micrometer. Try to zero that reading out as best you can and hit the 0. And I just fiddle with that a bit more and make sure I have the low spot. I went through this process already, I'll call that 0 for now. And basically just bump my way down the dovetail and keep repeating that measurement. Now again, this is just sort of a reality check, kind of a gut feel. I wouldn't base any kind of actual scraping or precision work off of one of these. But if I make some bonehead error with the indicator, at least I have some number to kind of flash a big red light and say, hey, why the big difference? That said, this thing came in actually remarkably close. So then finally I kind of put together one of these little dovetail thingamajiggies. I didn't make this very adjustable. This is specifically for this size saddle dovetail. I hope not to be doing too much of this machine rebuilding. Again, we're still measuring over pins here. And the idea is that we drop this down over the pins, and I'll try to get a better camera angle on the clock face. I've just got a pressed in pin on one side. This side's got the indicator dovetail holder with just a little set screw. I've got a little bit of a fine-tune adjustment in out there, and then of course the friction setting on the indicator itself. Put the pin over one side here and slowly drop this down until I'm contacting the center height of this back pin. And here what we're looking for is that minimum reading, and what I do is just lightly sweep it left to right, and you can see we're in sort of the range of the we're using the first few thou of the indicator reading. If I pick this up off the pin, it'll drop, come back up. I sweep till I find essentially that lowest point, and then carefully try to zero this dial out. Check it again. And that's now my reference 0. Carefully pick this up, move my pins down a bit, and kind of repeat the same process. Call that 6 thou, and I'll slowly pick that up. And what I did was mark that on the dovetail. You can see actually I think the digital caliper here was 6.5 thou. I mean, the ½ thou is a gamble in the digital calipers, but I'm getting 6 thou, so just trying to get some ballpark numbers here. So just a quick note with one of these little, measuring across dovetails like this. This isn't exceedingly accurate at this point because these surfaces, so I'm trying to measure the distance in the direction of this little support bar, but there's also a lot of wear still on these flat surfaces. Now the pin, the location of that pin is determined by both of these surfaces because it's sort of sitting down in that dovetail. I mean, just to give you sort of a sense of sort of an order of magnitude error, 10 thou wear in this surface here on the flat surface equates to about a 7 thou error in this width reading. So now that's pretty huge. I mean, that's quite significant. But again, at this point, I'm just trying to get a gross picture of where all the where the wear has happened and what it looks like. Once these surfaces get machined in and these dovetails get machined in, I'll scrape these surfaces, the flat surfaces, up against the master, which is the table here, and then repeat this measurement before I get into cutting the insides of these dovetail surfaces. Hope that made sense. Well, I struggled a bit trying to figure out how the heck I was going to machine, hold this gib. And then I realized I have a magnetic chuck. I've never actually machined on a magnetic chuck. This came right off the grinder table, but I figure I might give it a try. It's sort of an easy way out. I put the reference surface down, turn the magnet on, and hopefully take very light cuts. I put it on the mill table, put some good parallels on there, and just tried to level it up. I had to use a little paper in the corners and all that kind of stuff to get it all in. I'm golden left to right. That's a half thou indicator. I'm off a little bit front to back, but I'm not sweating that too much just because this thing is so thin. So let's get it on there, pack it in, and try to take these cuts. Alright, not too shabby. Let's take a look and see what we got. So this end, about 0.485. In the center we're a hair below 485. And on the end, the other end, about 486. So a thou variation along that 25-inch gib. I'll take it. Okay, so the surface plate and the indicator seem to jive with that micrometer reading. I've got about a thou variation across the length. But now something strange has happened. This was already flat, and now if I hold the center and push the end without rocking it, I'm picking up about a thou of bow. If you guys see that thou movement in the indicator. So I don't know, it's either something about the magnetic chuck or the fact that we took 20 thou off the ends of this imparted some bow. Okay, so let's see if we can get that 1 thou bow we just measured back out of this gib. I've got the gib in some soft jaws in the vise, and I got my pipe right. Alright, let's start trying to flatten this thing out. There were some questions last time from the straight edge video that I don't know if I ever really answered, but to clean my surface plate, I don't know if this is really the best thing to use, but I just use Zippo lighter fluid, or any lighter fluid. Leaves a little bit of a white haze, but it does a good job of getting the blue off. And for blue, I have this Permatex, I don't know if that'll focus, Permatex non-drying Prussian blue. I think I just got it from McMaster. I originally got a couple of tubes of these for checking like fits of like conical and cylindrical fits and bearings and stuff like that. So I had it around and I used it for this. But this tends to get really hard to see when you're getting to sort of the final stages of the scraping. I ordered some Dykem High Spot, I think it's called. It's the only other one I could easily get from McMaster. I've seen some red stuff and some different color stuff and people doing 2 or 3 different colorings. And it's probably a lot better for your eyes, but that's what we got and that's what we'll be using. And then this is just a little speed roller. I think I still have the box somewhere. Speedball 4-inch 10-centimeter roller. I don't know if I got this from Amazon or where this came from. So this is the first spotting right off the mill. I just broke the edges here a bit with a hand file. This is going to be a little tricky because this tends to easily flip. Alright, so I think it's typical for me of my first spotting pattern, just a couple of odd bits here or there. So I'll go through a couple of these cycles, and I'll be back when we start getting a little bit more continuous transfer across that whole surface. I have to admit, this mag chuck's turned out to be pretty darn handy. I'm going to use it for the scraping too. Just want to give myself some space there. Alright, so that's not going anywhere. Okay, so the gib has started spotting in along its whole length, and now the strokes are getting, a little bit more evenly distributed. If anyone's interested, this the smaller scraper again is just some carbide, and I tend to slap together just whatever I happen to have on hand. I have these are inserts for parting tools. I don't have the parting tool holder on it. I think I got this for like a few dollars somewhere. But carbide is carbide, and that's just brazed on to a piece of like a 1/4 inch round. Now I sharpen these by hand, or the larger ones on these DMT plates. But with these smaller ones, I find that we're almost the same size as the holes in the plate, so they tend to hang up, and it's hard to get consistent results. So I just come over to this is just like an import diamond wheel on an old grinder. Might not be pretty, but does a heck of a job. Okay, so I don't know if you guys can make that out, but it's printing along the whole face. It's looking pretty decent. I just refreshed the plate, so the bluing's a little bit heavy, but the previous rounds were all, telling me the same story. There's a couple of little low spots around the edge. That might have been my fault where I rolled a little bit with a file, but I think 1 or 2 more passes should get this in pretty good. Alright, so we're 483. I don't know if that focuses down on one end. There's not much land here for the micrometer. It's 483 in the center, and 483. Okay, so we've got that gib straightened out, I think. No pun intended. That fits in like that. Let's just go back through and take some measurements here, and again, make sure we did what we set out to do. So on this end, I'm looking at 1855, probably a few tenths under that. 54, a few tenths over that. And at the get-go here, looks like I'm 1854 exactly. So within a thou, probably less than that across the 25-inch length. Again, if this was a tapered gib, that'd probably be a no-go, but because it's a straight gib, I think we're golden. Just for kicks, I'm going to use this as just a little straight edge. This means absolutely nothing probably just because it's so floppy. But if I set that up against the machined surface, I'm not really seeing any wobble at the ends. Looks like a good tight fit. And again, that's expected. Let's try that against our worn, still to be repaired dovetail. Get that in here. I don't know if you guys can see that bow that's happening in the middle, right there. It's sort of seesawing on that end. Alright, so that's it for now. Wait for the dovetail cutters to come in. We'll tackle the saddle next. You know, this I was really impressed by how this little magnetic chuck worked out. If I ever upgrade to, you know, like a better one of these, or like a fine pole, if I ended up using this surface grinder, that's definitely a keeper for these random, odd, thin little pieces. So again, thanks for watching. I hope you guys are enjoying this, and we might get there yet. Till next time, take care.